All right, let's talk about exponents for IB math, the kinds of things you're going to see that you're going to be expected to do, all that kind of stuff. We've got a couple things we're going to hit: common bases, simplifying, solving, and the biggest one, rational expressions, or rational square roots and radical expressions. So let's get into it. So first thing first here, let's see. This one, common bases. So sometimes you're going to have to simplify something like this, and the thing you have to be aware of is that this can be expressed as a base of 4. So, 16 is going to be equal to 4 squared, right? So this is going to be 4 times 4 squared to the power of 4. And then, of course, if you have a power raised to another power, you can multiply those. 4 times 4 to the 8th. And then this has an exponent of 1, even though it's not written. It's always there. If the bases are the same and you're multiplying, you add the exponents. So sometimes you're expected to do something like that, or sometimes that kind of skill can make a complicated problem very easy for you. Okay, so got common bases down. Now let's talk about simplifying. These can seem really overwhelming. It seems like there's too much stuff going on, but I think if you look at it like this, look at those numbers together, right? And you simplify those, and then separately you look at the x's and you look at those as if they're their own problem, and then you look at the y's together, and then you look at the z's together. It's not so bad. It's much more manageable. You just take one little step at a time, right? So let's do this first. This is just reducing. It's 15 over 25, so this is, of course, 5 and 3, and this is 5 and 5. So that part's going to become 3/5, right? Okay, I kind of lost my exponent of 2 there with my little blue box. Here, the bases are the same, and we're dividing, so we subtract top minus bottom. Or the way I think about it is I've got 3 up here, 2 up there. It's just going to reduce like this. You see? The x is reduced. You're left with just 1x on top. Okay, this is something, it's just something divided by itself, so it just equals 1. But if you wanted to do top minus bottom, -2 minus -2, well, that'd become y to the 0, which is, of course, just 1. Since I already have a whole bunch of other stuff, I don't have to multiply, or I don't have to write times 1. Last one, negative exponents being reciprocal. So this has a negative exponent right here, which means I'm going to have it move to the bottom. I already have 5 there, so that's going to give me 10 of them there. If you wanted to write it out like this, you would do, right, like the division is subtraction, so that would be z to the -10, which is, of course, 1 over z to the 10. However you do it, it doesn't really matter. I like to just think about it like that. So give you another example. Let's say we had x to the -5th and y to the 7th, and let's do this. Let's make that -7 and squared. Okay, so look at this. See this x to the 5th up here? That's got to go down to the bottom, right? And there's already 3 of them there, so that'd be 8. This x or y to the -7, it's going to go up to the top. There's already 2 of them, so that's 9. That's how I think about it. It seems to be very fluid and pretty simple if I do it that way. But nevertheless, simplifying, we're done. Now, solving for something like this involves both of these things. If I can rewrite these numbers so they have a common base, then it's going to be pretty easy, because if I can get, like if I had a base of 7 and I had a whole bunch of stuff up here and it equaled 7 to some other stuff, then the exponents would be equal to each other. So that's what I'm going to do here. See, 32 is 2 to the 5th, right? 2, 4, 8, 16, 32. 1, 2, 3, 4, 5. Yep. And 8 is 2 to the 3rd. So this is going to be 2 to the 5th to the power of x divided by 5 equals 2 to the 3rd. Okay, so I got to simplify this right here. I have a power raised to a power, so I have to multiply those. See, if I have x divided by 5 times 5, well, it's the same as 5 over 1. Those are going to reduce. That's just going to be x. So what I've got is I've got 2 to the power of x equals 2 cubed, so x equals 3. Yeah, let's do another example. This one's a little trickier. It's a little easier to see what's happening right here because this can be written as 5 squared. So what I've got is this part stays the same, 5 squared times 5 to the 2x. Now, here we're multiplying and the bases are the same, so I have to add. That's going to be 5 to the 2 plus 2x. So now I have bases the same, right? 5 to a power equals 5 to a power, so that means those powers have to be equal. So now I can solve. I'm going to move the 2 over there by subtracting it. I'm going to move the x over there by subtracting it. X is negative 1. That's it, right? 2, or negative 2 plus 1 is negative 1. Just move it. Boom, we're done. All right. Now, the most important thing is this. This is the most important thing you're going to see when you're talking about exponents that come up in IB math. So the way I always remembered it is when I was a student, I know that 4 times 1/2 is 2, right? 4 times 1/2 is 2. Now this is to a power of 1/2, and I just always remembered it was 2, and that helped me to see if I was setting it up right. The square root of 4 is also 2, so that's correct. That's just 2. That's how I always remember. The numerator is the exponent, and the denominator is the index. So 8 to the 2/3 power would be the cube root of 8 squared. So that you could simplify that further if you wanted, but the most important thing is that you're recognizing how to rewrite one to the other. So if you had, say, like the 5th root of 2 to the 3rd, and you needed to rewrite that as an exponent, that would be 2 to the power of 5 over 3. Yeah? Now let's talk about simplifying this one real quick. We're looking for a perfect cube. That's 64. 8 squared is 64. So 64 is 4 cubed. So anyway, exponents come up quite a bit, not as their individual own question in IB. They often come up in applied questions, especially in calculus. So when you get to the calculus unit, this stuff's going to be pretty big, but they come up in finance quite a bit, and geometry, and of course the functions unit. So they come up all over the place, but they're usually not their own topic. So with that said, you've got to really have these things in the back of your mind, how this all works, because, well, you're going to have to be able to do those things without being told, hey, this is the step you have to take. So anyway, I hope this was helpful, and I hope you have a great day.